Hello, grade 8s. I hope you're doing well. Today we're going to cover the topic of geometry of straight lines. And before we get into it, please don't forget to like our videos, subscribe to our channel if you haven't already done so, and please do share these videos with your classmates. Remember, we're trying to make maths accessible to those who don't have access to good teaching. We're also trying to make it, look easy because it's not as bad as we make it out to be. And yeah, let's get maths fashionable and possible, right? We can definitely pass it if we spend time with it. So let's get to it. Now, in terms of straight lines, what we're going to start with is the angles that form on a straight line. So you can have a straight line and have 100 gazillion angles that are formed there. But the one thing you should know and remember is that the sum of angles on a straight line equate to 180 degrees, okay? So when you add up all those angles, all right, even if you had to have a straight line like this, and like I said, from a point, just have a whole lot of lines or angles that form, when you add all of them up, regardless of how many there are, you will always get 180 degrees. All right, because on a straight line, the angle that forms there is 180 degrees. If you take your protractor, put it on a straight line, you will see you will get 180 degrees. So that's the first thing. Please do not forget it. And whenever you have angles adding up to 180 degrees, another term we refer to it is that those angles are actually supplementary. So you could say angles on a straight line are supplementary, or the sum of angles on a straight line equate to 180 degrees. So looking at our sketch over here, we know that angle A, angle B, and angle C are equal to 180 degrees. Now in maths, we try to work with symbols as much as we can. And remember I said you can actually pass maths when you spend time with it, meaning when you practice often. So when you spend time with maths, you will realize that we don't actually write out angle A. By the way, if I write it out as angle A, I need to accompany it with a hat. So the A will have a hat. So I'm not going to put the angle A. So basically, angle A, we write it like with a slanted L. Okay, that's how we indicate angle. And basically, if you were to have a line and you have an angle over there, that's why we put it in a slanted manner, and we don't put it like that, like an L. It is slanted. Okay, so going forward, if we want to write angle in a simple manner, we're just going to use a slanted L. All right, so angle A, angle B, and angle C all add up or equate to 180 degrees. Now, secondly, we're going to talk about angles that form between two intersecting lines. And we often say that angles formed between intersecting lines which are vertically opposite are actually equal. Okay, it's important that those lines are straight. After all, we are talking about straight lines. So I don't want to see lines that form randomly and then you're like, oh, okay, since these ones are vertically opposite, they must be equal. No. Those are not going to be equal. Okay, it must be an actual straight line. Then these angles that are vertically opposite, they will be equal. Okay, and according to the sketch, we can then see that angle A is equal to angle C and angle B is equal to angle D. All right, so those are vertically opposite angles. If you're going to write it simply, you can just say vertically like that, opposite angles. Okay, you don't need to write out the entire thing. Okay, and then thirdly, we're going to look at lines that are perpendicular. And what about those lines? So basically, lines that form an angle of 90 degrees between them are actually perpendicular to each other. So if you have lines that are crossing each other and you measure the angle in between the lines and you actually find that it's 90 degrees, then you know that those lines are actually perpendicular. All right. So that's basically that. And we can see here then that actually line AB is perpendicular to line CD because we see an angle of a 90 degrees, okay? And if you were to measure the angle this side, you also get 90 degrees. The angle that side, that's also 90 degrees. The angle there is 90 degrees. And all these angles add up to 360, okay? But basically, angles or lines that are perpendicular to each other, they form 90 degrees angles in between them, okay? And line AB, as we said, is perpendicular to line CD, and this is how we write it simply. Okay, we're going to say line AB is perpendicular to line CD. We indicated with that upside down T. Okay, and then now fourthly, let's talk about angles around a point. So basically, angles around a point add up to 360 degrees, okay? Or we can say that basically those angles form a revolution, meaning again, they add up to 360 degrees, all right? So basically here we can say that angle A plus angle B plus angle C will give us 360 degrees. And so far we've covered with straight lines three angles. We've talked about 180 degrees, that's angles on a straight line. We've talked about 90 degrees, and those are angles that are perpendicular to each other, or lines that are perpendicular to each other form angles of 90 degrees. And now we're talking about angles that add up to 360 degrees, which is basically angles around a point. Okay. Now, there's another concept I would like us to talk about, still there with the straight lines. So what happens when you have what we call parallel lines, okay? And these parallel lines are cut by a transversal. So parallel lines, before we get to the transversal, what is a parallel line? So I've heard this math joke. It says parallel lines have so much in common, it's a pity they can't meet. And yes, not that they don't want to meet, they genuinely cannot meet. They have so much in common. What do I mean by that? They have the same gradient, they have the same distance between them, but they just cannot meet, no matter how hard they try. So how do you know you have a parallel line? Is if the spacing in between the parallel lines is the same, then you know. Or rather, if the spacing between lines is the same throughout, then you know you have a parallel line. So for example, here you could have 5 centimeters and you measure over there. You also have 5 centimeters. If you measure, if I extend this line, okay, extend it, I should still get 5 centimeters. Okay, so I extend it over there, and there I go. I should still measure 5 centimeters. That measurement should not change. And that is what constitutes a parallel line. All right. And if you can establish, or you have been told that lines are parallel, then you are excited because you can use that information to benefit you. How would it benefit you? Before I talk about the benefits, the fun benefits, let's talk about this transversal. So, like I said, lines are parallel between them. And if you were given lines and they asked you, how do you know that these lines are parallel? Just measure the distance between them. Okay, measure it. And once you measure the same distance throughout, you know that the lines are parallel and that they will never meet. All right, so now parallel lines can be cut by a transversal. Okay, now what is a transversal? So a transversal is a line that passes through two lines. It can be any two random lines. Okay, they don't have to be parallel, but yeah, basically that. But in this case, we are referring to a transversal that basically cuts through two parallel lines. Okay, and it's important, like I said, we cannot use the knowledge about parallel lines in a fun way if we do not have a transversal. So we need that transversal. So let's have some fun. Let's talk about this fun. So whenever you hear that you have parallel lines, you must think of three things. F, U, N, all right, or F, C, Z. Okay, so you can have a C there and a Z there. But for the sake of keeping it funny or keeping it having fun, we'll just stick to fun there. All right. And now let's talk about F. Okay, so F, basically you have two parallel lines. And if you see that you can form an F, then you know, okay, fine, below these parallel lines, angles can form. Now what happens to these angles? These angles are actually corresponding. Now if I said I have corresponding angles, what does that mean? Okay, like here as well, these lines are parallel, so these angles are corresponding. These lines are parallel. Now these angles are corresponding, and lastly these lines are parallel and the angles are corresponding. So what are these corresponding angles? Okay, before we even get there to the definition, let's just highlight corresponding angles. So I see I have an F over here. Do you see that F? And the angles below the parallel lines, remember these are the parallel lines. So I have angle C and I have angle Y. All right, can I see another corresponding angle? Yes, I do. Still on the same side. I still see this F over here. Okay, and I see A and W as corresponding. Is that it? I still see some more on the other side. So I have that line over there, that line, and below the line or on top of the line, I have angle B and X. I also see another one, the last one. Okay, so there's an F over there that forms. If you see any more that I might have missed, please do comment below. So below the parallel line, I have D, and I also have Z. Okay, so that's how you would identify corresponding angles. All right, see, it's not so bad. So now let's continue again. Remember what I asked, what are corresponding angles? We see that it's angles that if you form the F between parallel lines and the angles are below the parallel lines or above the parallel lines, as we have seen, then corresponding angles are equal. Okay, corresponding angles are equal. And over here, which angles are corresponding? Well, we did mention that we have B and X. Okay, I'm going to indicate B with the hat on top. So B and X are equal. A and W are equal. All right, angle A and angle W, angle C and angle Y are equal. And also angle D and angle Z are equal. So that is basically corresponding angles. So part of fun, that's the F. Now let's go to the U or C. And really that all depends what you see when you're looking at your sketch. Oftentimes I see C, not so much the U, all right? But if you do see a U as well, it is applicable. So those angles then would be referred to as co-interior angles, okay? You have your lines that are parallel there, you have one angle there and another angle there. Those are co-interior angles, okay? There we go. So we have that and that, this angle and that angle, that angle and that angle. Now what about the co-interior angles? We've already spoken about corresponding angles, that those angles are actually equal. What about co-interior? Will they be equal or what? Let's see if we can identify some co-interior angles before we get to what the angles actually are. So I can see here, if I form a C, okay, if I turn my screen around 90 degrees clockwise, I will see a U, a U that is slightly slanted. And I see the angles here, C and W, but what about C and W? Are they equal just like the corresponding angles, or do we apply different rules there? Okay, so there we go. angle D and angle X are actually co-interior angles. So yeah, I can't see any other C or any U for that matter. All right, so that's basically all the co-interior angles. If you see more, please do comment below. Now it says co-interior angles are supplementary. Is it the first time you're hearing that word? Supplementary? So supplementary basically means it adds up to 180. I did mention it before when we started with straight lines. Yeah, if you heard it then you're like, oh, come on. I heard it before. It's not the first time I'm hearing this word. But yes, so supplementary means it adds up to 180 degrees. Okay, and as it adds up to 180 degrees, it means that C plus W is 180 degrees. Okay, that is what supplementary means. As you continue with maths, you will hear complementary. Okay, complementary meaning it adds up to 90 degrees. All right, so but now we're going to focus on the term supplementary. Even angles on a straight line, like we said initially, angles on a straight line are supplementary. They add up to 180 degrees. All right, so even here with co-interior angles, angle C plus angle W will be equal to 180 degrees. Also angle D plus angle X, that will be equal to 180 degrees. So we can then answer the question that asks which angles above are co-interior. So that's basically angle C and angle W, as well as angle A and angle X. Now we get to the last part of fun, which is the N. Most people see N's, I see a Z. Okay, so it's up to you. As long as you can identify quickly the Z's or the N's, then you're good to go. But yeah, that's the last part of fun. Like I said, when you hear parallel lines, think of fun. Corresponding, co-interior. So we know corresponding angles are equal. Co-interior angles are supplementary. Now, what about these ones that form a Z or an N? So these are called alternate angles. Okay, alternate angles. Now, can we identify some alternate angles over here? Please don't say alternating angles. It's literally referred to as alternate angles. Okay, so our alternate angles over here, we have C and X. All right, and let's just change the color. Then there's another one over here. Oh, okay. Okay, so this one just forms straight lines. Okay, let me just do that one again. So these are your alternate angles. Basically, D and W are your alternate angles, all right? And again, you have them. You must make sure that the arms or I don't know what you would call them, but those are actually parallel, all right? Those lines are parallel. The diagonal line can go whichever way, but the other lines are basically parallel. Remember guys, you cannot have corresponding alternate angles as well as co-interior angles if you do not have parallel lines. This only works if you have parallel lines. So what about these alternate angles? Like I said, with corresponding, we said they're equal. With co-interior, we said they're supplementary. Alternate angles are also equal, much like the corresponding angles. So if we were to identify which angles above are alternating, like we said, we have angle X there, and we have angle W there. So X is equal to C and W is equal to D. Okay, those are our alternating or alternate angles. All right, so still with the parallel lines, we can talk about vertically opposite angles. We did introduce that concept earlier on. And like I said, with vertically opposite angles, you need to have two straight lines that are crossing each other. It doesn't matter the angle, all right? They can cross each other at whatever angle. And then we know that vertically opposite angles are equal. So in this case, can we identify vertically opposite angles? Yeah, we definitely can. So B and C are one of them. All right. We also have X and Y that are vertically opposite. I hope that you can see that B is actually equal to X. Because of what? Because of corresponding angles. And also C is equal to Y, again because of corresponding angles. I hope you see that. So while identifying vertically opposite angles, you can also see corresponding angles. Hence, I'm using the same colored pen. Now we can also see that A is equal to D. And because of alternating angles, I know that D is equal to W. Alright? And again, I can see that W is equal to Z because they are vertically opposite angles. So in summary, we say that vertically opposite angles are equal. And can we identify them above? Yes, we can. Alright, so we know that A is equal to D. Angle B is equal to angle C. Angle X is equal to angle Y. Angle W is equal to angle Z. And those are your vertically opposite angles. Now we can start with an exercise. We're basically done with the theory. Alright, so exercise 1, it says classify the following angles as vertically opposite. We just spoke about that. Are these angles alternate? Angles at a point or around a point? If these angles are in a straight line or they are perpendicular. Okay. Okay, so let's have a look. Alright, yeah. Now, A, we have angles A, B, E, and F. Okay, so we have A, B, Aibo. Okay, sorry, I had a typo there. It's supposed to be E and F. Okay, I had a double C and D. So A, B, E, F. There we go. So basically, if I look at this quite clearly, this is forming like a revolution. Okay, so what am I going to say about that? So if you look at our options here, we have vertically opposite angles, and we know that vertically opposite angles are equal. Alternate angles, those are the ones that form a Z. Those are also equal. Angles at a point, those are equal to 360 degrees. Angles on a straight line, those are equal to 180 degrees. And perpendicular angles, those on the angle, perpendicular lines actually form a 90-degree angle between them. Okay, but looking at A, B, E, and F, I see option C, which is angles at a point. So we can write that as our answer. So that's basically angles at a point or around a point. And then angles A and F. So basically this is A and that's F, and we can see there, it's clear as day, that we have vertically opposite angles. Now angles B and F. So angle B and F, what do you think? For me, I see that this B and F is along the straight line. Okay, so basically angles B and F are angles along a straight line, right? And option D, or angles that are supplementary, but we'll stick to that, angles on a straight line. All right, and then angles B and E, again, okay, so basically that's B, that's E, and we can see clearly that B and E are vertically opposite angles. Forgot to change the color pen. All right, and then how about angles C and G? Oh, again, angles C and G are there. They are basically are angles on a straight line. Okay, so that's angles on a line. So that wasn't so bad, right? We managed to answer all those questions. Let's just see what we didn't actually get there. Did we use all the options available? Did they put others there just to throw us off? I don't know, but let's have a look. Okay, just wanted to make this the same as the others, but it doesn't want to change. That's fine. So let's see. Vertically opposite angles, yes, we did use. Alternate angles, no, we didn't, but you could see alternating angles or alternate angles there. It would be basically angle C and F or angle B and G, but they never asked it, so we didn't get to use it. Angles at a point, yes, we did use that. Straight line, perpendicular angles, no. I mean, even if you look here, I don't think anything that forms between these straight lines would be 90 degrees, right? So that's okay. We can then move on to the second question. If this thing doesn't want to change color, it's okay. I'm just going to leave it at that. It just looks so awkward all by itself. So let's see if that can change. If it can't, like I said, let's just move on to the next exercise and call it a day. Right, exercise 2. It says if angle O is 67 degrees, so there we go. Find the size of I. Okay, there is I. What do I know about O and I? What's common between them? Can there be an alternate angle maybe? No. The only alternate angle is O and J. That would be equal. And I can use that to get I, but let's see. Co-interior angles? No. Corresponding angles? Well, if I went with corresponding, then I would get this F over here, right? Again, I would be equal to M and not necessarily O. So I can't use fun in isolation. I can use a combination of fun. Vertically opposite angles? Yeah, no. So here I'm going to have to use a combination of fun. All right, I can then say, let's look for angle M. All right, so we're looking at angle O and angle M. And I know those ones are on a straight line. So that's where we're going to start. So basically, I know that M plus O, because angles on a straight line are supplementary, right? They are equal to 180 degrees. If O is 67, then we have 180 minus 67 degrees. All right, and what is 180? Well, 180 minus 70, that's 110, and 110 minus 7, that's going to be, it's going to be 3. So basically, 180 minus 67 degrees will be equal to 113. So that is M, right? If I have M, which has 113, then I can go on to say I and M are equal. Okay, but I have to, am I going to give reasons? Yeah, let's give reasons. M and O are equal to 180 degrees, and that's basically angles on a straight line. All right, and then I would be equal to M. Why? Because those are corresponding angles, and I need to state which lines are parallel, and I didn't give them labels, so let me just say this is line A, B, C, D. This is me doing extra. They didn't ask for reasons, but I want you to get into a habit of supplying reasons, okay? So basically we have corresponding angles and which lines are parallel, basically AB parallel to CD. Okay, so now ultimately I is going to be equal to 113 degrees. Now what is J equal to? Okay, J and I are actually on a straight line, they're supplementary, but also J and O are equal. Why? Because of alternating angles or alternate angles, right? And basically, again, the alternate because we have AB parallel to CD. So O is going to be equal, sorry, J is going to be equal to O, which is 67 degrees. You see why it's important to know how to solve for X that you did previously, because you're not going to use it here in geometry. Okay. Now the third and last one, and then we're done with this lesson. Let us get the angle L. So this is L over here. Okay. What do you notice about O and L? Let me give you a few seconds to think about it while I hope you see that O and L are co-interior. Okay, so basically O and L are co-interior, meaning they're equal to 180 degrees. They are supplementary. What is O? It's 67. Okay, I'm going to do this a bit slower. That's 180. So if I want L alone, I'm going to say L is 180 minus 67 degrees, which we have worked it out before, and it's 113 degrees. Okay, so anyway, O plus L is 180. Why? Those are co-interior. That's how you write it. And again, you need to reference the sides or the lengths that are, the lines that are parallel, which is AB and CD. So L is 113 degrees. And if you didn't work it out that way, you could have said M is equal to L because of alternating angles. Okay, you can see it here. Alternating angles. L is equal to M, which is 113 degrees. And that's basically it. I hope you enjoyed this lesson. Like I said, if you haven't subscribed, please do. If you haven't liked it, please do like it and do share this video with your classmates. Bye.